So let's do a recording of vectors. This is x-axis, this is y-axis, and this is z-axis, which is represented as an I cap, a j cap, and a k cap in vectors. X and y, z are in Cartesian format. Generally, we say x, y, z. That's called Cartesian format. The moment you say I, j, k, that's a vector format. So you know a I cap, a j cap, and a k cap are just indicating the directions of x-axis, y-axis, and z-axis. The magnitude of I cap is 1. The magnitude of j cap is 1, the magnitude of k cap is just 1. They don't carry any magnitude, they just indicate the directions. So supposing you have a point P, which is it's called a position vector P, which is 1i plus 2j plus 3k, which means the 1 has come from the x-axis, the 2 has come from the y-axis, the 3 has come from the z-axis. That's what this position vectors i's, j's, and k's mean. So this is the position vector. So now I'm going to join this, and this is the origin, and the position vector is always with respect to the origin. You're going to convert this into line vector OP. Let's call this a 0, 0, 0, or a 0i plus 0j plus 0k, and the line vector OP vector is x2 minus x1. This is x1, y1, z1. This is x2, y2, z2. The line vector will be x2 minus x1 into I plus y2 minus y1 into j. So its formula is x2 minus x1 into I plus y2 minus, you can also say y1 into j, plus z2 minus z1 into k. So then therefore in this case it will be 1 minus 0 into I plus 2 minus 0 into j plus 3 minus 0 into k. You got a line vector. This is called line vector. You know two position vectors, you can convert it into a line vector. Similarly, supposing this is a vector and this is b vector, it's not the origin, it's some vector 1, 2, 3, and this is called 3, 5, 7. So they ask you to write the line vector. You know this is x1, y1, z1. This will be x2, y2, z2. So the line vector will be x2 minus x1 into I. So 3 minus 1 is 2i. A 5 minus 2 is 3j. And a 7 minus 3 is a plus 4k. So this is how you frame a line vector. Suppose they ask you to find a magnitude of the vector. The magnitude simply means root of the component square. You know in a 2 dimension, you get 1 from the x-axis and a 2 from the y-axis. It will be 1 comma 2. This distance will be 2. 2 from the y-axis, 1 from the x-axis, 1 comma 2. And this radius will be root of 1 square plus 2 square. Like that, the magnitude of AB, you have 3-dimensional figure, okay, wherein you have a vector which is an AB vector. So then what was I about to say? So you want to find the magnitude of it. Okay, in this case, the magnitude of OP vector. What is the magnitude of OP vector? Is root of 1 square plus 2 square plus 3 square, which will be root of 1 plus 4 plus 9, which is root 14, which is nothing but this radius. The magnitude of this length, whatever it is, because in 2D it is x square plus y square, if it's xi plus yj. In 3D is x square, the coefficient square, root of the coefficient square. So in this case, what is magnitude? It's 2 square plus 3 square plus 4 square, which is root of 4 plus 9 plus 16, which will be root 29. So how to convert a vector into unit vector? Unit vector is vector by its magnitude. So then it will be 2 by root 29 into I plus 3 by root 29 into j plus 4 by root 29 into k. The vector by its magnitude will give me a unit vector. Unit vector is always represented as cap. So if you find the magnitude of this, which is squares of this components, it will be 4 by 29 plus 9 by 29 plus 16 by 29. It will be 29 by 29, which will be just 1. So there's no wonder we call it as a unit vector. Unit vector is one whose magnitude is unity. So you know this is a unit vector. Okay, whereas this is not a unit vector. AB is not a unit vector. So then that coefficients, that is the 2, 3 and 4 are called, we don't call it coefficients, we exactly call it as direction ratios, DRs. Where when it is not a unit vector, the coefficients called direction ratios. When it is a unit vector, we call them as direction cosine, DCs. These are all unit vectors, so it's called DCs, direction cosines. So you know, why is it called a direction cosine? Let's see. You know that this is a 2, 3, 4 is this point, where 2 has come from the x-axis, 3 has come from the y-axis, 4 has come from the z-axis, and the magnitude is root of 29. Therefore, this is nothing but cos alpha. A 2 from the x-axis and a root 29. Cos alpha is adjacent by hypotenuse. The second term is nothing but cos beta. That is a 3 from the adjacent side and the hypotenuse. And again cos gamma, therefore no wonder they are called direction cosines. You can also call them as cos alpha into I plus cos beta into j plus cos gamma into k. You can represent this even like this. Since it's a unit vector, there's this new property that you get. The squares of the component should be equal to 1. Root of the squares of the root of cos square alpha plus cos square beta plus cos square gamma should be equal to 1. So squaring both sides, you have cos square alpha plus cos square beta plus cos square gamma, which is 1. You can also write it as 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma is equal to 1. So then this is 1 plus 1 plus 1, 3, 3 minus 1 is 2. Take all this to the other side. So you take the sin square alpha negative to the other side, sin square beta to the other side, plus s square gamma to the other side. So you'll get the answer to be 2. This is something that came for a board exam. Children knew this, but they didn't know what is the value of this. I can't understand what is their issue, why they are not even able to think these days, especially after COVID batch. Okay, so that's about it. So next thing that I want to teach you is about parallel lines. Supposing you have two parallel lines, that is, this is A vector and this is B vector. The condition for two vectors to be parallel is one vector should be lambda times the other vector. See, for example, if this is going to be 1i plus 2j plus 3k, I can multiply the whole thing with a 5 or a 7 or whatever. The lambda can be any number. So it will be 7i, I'm multiplying with 7 plus 14j plus 21k. The fact that the ratio is this, it's 7 times. This is 7 times 1i plus 2j plus 3k shows that it's lambda times, when lambda is 7, shows that these two vectors are parallel to each other. That's a condition for parallel vectors. This is in vectors language. In a layman's language, as Cartesian language, we can also say, let's call this as A1, B1, C1. Let's call these coefficients as A2, B2 and C2. In that case, you can also say A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to lambda. So if you look at this, 1 by 7 is equal to 2 by 14 is equal to 3 by 21 will always be 1 by 7, which is equal to lambda. So there are two ways of inferring that they are parallel. One is the vector is lambda times the other vector, it's parallel. Otherwise, the ratios of the coefficients is always a constant. That is another way. A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to lambda is a condition for parallel vectors. Now, let's talk about perpendicular vectors. Let's talk about perpendicular vectors. Condition for two vectors, this is A vector and B vector. The condition for the two vectors to be perpendicular is the dot product is equal to 0. Here what is it? One vector is lambda times the vector for parallel. But here in vector form, a dot product is equal to 0. What is the meaning of dotting? I'll just tell you what is the meaning of dotting now. So you know that, let's call A vector to be 1i plus 2j plus 3k. Let's name B vector to be 2i plus 3j plus 4k. Let's name some two examples and do a dotting. A dot product means it's 1i plus 2j plus 3k is getting dotted with a 2i plus 3j plus 4k. Okay, a dot product in itself, the formula is magnitude of A into magnitude of B into cos theta. A physics student will know it readily, but for a commerce student who won't know, the dot product means involves cos theta. Magnitude of A into magnitude of B into cos theta. The fact that there's cos theta, theta has to be 0. If theta is 90, then the whole vector will be, dot product will become 0. You understand? So if they're perpendicular, obviously theta will be 90. So it makes sense for us to say the condition for two perpendicular vector means dot product has to be 0. Because the dot product involves a cos theta and the theta is 90 in perpendicular, so dot product will become 0. So in general, how do we dot it? You know theta is equal to 0 is when it's acceptable. Theta cannot be 90. So you cannot dot an I and a j because I and j are perpendicular to each other. X-axis and a y-axis, right? So you can only dot an I and a I, j and a j, k and a k. So when you dot, you get 1 2s are 2i square, but I square is just 1. And 2 3s are 6, j square is just 1. 4 3s are 12, k square. So you just do it like this, and so the answer is 20. So then you get a scalar. 20 is not a vector, 20 is a scalar. There's no I, j, k, anything in it. So it's called dot product, is also called a scalar product. Thus you understand a dot product. A dot product is called a scalar product. Why is it called a scalar product? Because you get a number finally. You don't get an I, j or k. The vector disappears. Okay, and it involves cos theta, and therefore the condition for two perpendicular vectors becomes A dot B is equal to 0. This is in vector form. Suppose in layman's language or in a Cartesian format, I want to say, I can name the A vector as a1i plus b1j plus c1k, and b vector as a2i plus b2j plus c2k. And dot product means just dotting the i's and i's and j's and j's and k's and k's. So the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So you should memorize both. So what is it? For perpendicular vector, the dot product is equal to 0. For perpendicular vector, it's also a1 a2 plus b1 b2 plus c1 c2 is equal to 0. For parallel vector, one vector is lambda times other vector, or a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda. Like that, you should memorize each and every condition clearly. Next, I taught you what is a dot product. Now that you know what a dot product is, nothing but magnitude of A into magnitude of B into cos theta. Suppose you have a vector and a B vector, and a theta is the angle between them. You can always find cos theta using this, which is A vector dot B vector by magnitude of A into magnitude of B. Correct? So cos theta itself is A vector dot B vector by magnitude of A into magnitude of B. So this is the formula. I will always say this vector dot that vector by magnitude of this into magnitude of that, whatever be the vector. Correct? Let them give you C vector and D vector and ask you to find angle between them, and C vector dot D vector by magnitude of C into magnitude of D. So that's how you find the angle between the two vectors. Yeah.
So how do you find this A vector into B vector? If A vector
into A vector dot B vector. I told you can only dot. A vector will be 1i plus 2j plus 3k. A B vector will be 2i plus 3j plus 4k. And you dot, you can only dot an I and a I, j and a j, k and a k. So you'll get this. And you know how to find the magnitude of A, which is root of 1 square plus 2 square plus 3 square. What is magnitude of B? Root of 2 square plus 3 square plus 4 square. So just plug in the values, and hence you can find theta, and you can write theta to be cos inverse of that value. Theta cos goes that side, it will become cos inverse. You understand?
Yes.
Cos theta when goes that side, it will become cos goes that side, it will become cos inverse. Anyway, I'll be teaching you inverse trigonometry very soon. Okay, that time you will understand what it is. So next, I'm going to teach you what is a cross product. So the moral of the story, therefore, in dot product, you can only dot an I and a I, a j and a j, a k and a k. I have this peculiar tune which I use, so from which you can dot product only dot an I and a I, a j and a j, and a k and a k. But cross product, what does cross product mean? First of all, you should understand this. The formula for this is magnitude of A into magnitude of B into sine theta. A cross product is a vector product. So therefore, you have to continue writing an n cap to show that they will still retain its vector form. Okay, so then to cross it, I'm going to teach you one small technique. Write an I here, a j here, and a k here. An I cross j will be k. A j cross k will be I. A k cross I will be j. But if you do other way around, then it will be minus j. I cross k will become minus j. It should be necessarily in the clockwise direction. If anything is in the anti-clockwise, you should write the opposite symbol for the other. Okay, are you clear? So when I say a cross and 1i plus 2j plus 3k, which is an A vector, is to be crossed with a 2i plus 3j plus 4k, which is a B vector. When I ask you to cross it, you obviously can cross only an I and a j. Because why? Because it involves sine theta. Sine 90, so it's 1. So therefore it has to be perpendicular. You can never cross an I and I crossing will be 0. So you can only cross an I and a j, I and a k, j and a I, j and a k, k and a I, k and a j. And while crossing, you have to apply this formula and plug it in. See, for example, 1 2s are 2. No, you can't do 1 2s are. You have to do 1 and 3. 1 and 3 is 3. I cross j. What is I cross j? K. So it will become 3k. Next, 1 with a 4 will be 4. I cross k. What is I cross k? J. It's in this direction, no? Minus j. So then therefore it will become minus 4j. Right. Then what should you do? You would finish with 1, take 2. You have to do 2 with a 3. No, 2 with a 2. J cross I. 2 to 4. J cross I is minus k. So minus 4k. Yes. Like this, if you keep doing, I am capable of making mistakes. So I'm not going to teach you. This is for your understanding. But however, I'll teach you a shortcut to learn to do this using determinants way. What you do is write I, j, k. You want to cross, you just do determinants. So write this 1 here, this 2 here, this 3 here. Right? This 2 here, 3 here, and 4 here. This vector here. This vector in the first line and this vector in the second line. Are you clear? And then straight away do a determinants. You know how I'm going to anyway teach you determinants next class. I've just stopped it just so that you can learn this and I can move to the determinants. Okay, now I'm freezing one of the rows, which is this row. While doing determinants, this should be positive, negative and positive symbol, should carry that symbol. So then therefore it's plus I into minus j into a plus k into, write it like this. You've frozen the first row, you write I into j minus j into plus k into, never forget the minus j. Now when you're doing I into, you have to omit that row and that column and do top to bottom minus bottom to top. What it will be? 8 minus
9.
8 minus 9. Top to bottom minus bottom to top. Never interchange the order. Are you clear? So it's 8 minus 9 is minus 1. No, minus j into. I've used a different color. So this row, this column has different color. I'm saying different color. I'm using same color. Okay, I have to omit this row and this column and do top to bottom minus bottom to top, which will be 4 minus 6, which will be minus 2.
So that will be plus 2j.
So plus 2j, yeah, later. Okay, now k into. So that row, that column needs to be omitted and top to bottom minus bottom to top. 3 minus 4 is minus 1. So the answer for this therefore will be minus 1i plus 2j minus 1k. And did you see that when you cross you get a vector? That is why we stuck to saying an n cap here, and that is why it's called a vector product. So this is an easy way of finding a cross product of two vectors. Are you clear? So supposing they ask you the magnitude of this, root of 1 square plus 2 square plus 1 square. You don't have to take the negative symbols because anyway it will all become positives when you square it. So that's how you find the magnitude of the vector. You want to convert this vector into unit vector, take that vector and divide it by its magnitude. Are you clear? So that's about, this is how you cross two vectors. Okay, so the most important point that I would like you to know, like supposing on a table there are two vectors. This is A vector and B vector. This is on the table. Just keep a pen on the table, 2 pens on the table. That is one pen and that's the other pen. You want to find a vector which is perpendicular to those two vectors, which will be literally perpendicular to the table itself. You want to get a vector which is perpendicular both A and B. Can you imagine A and B is in the plane, xy plane. You have to cross A and B. I call it as scissors. Never forget this because children tend to forget this. You have to cross A and B so that you get the C vector which will be perpendicular to both A and B.
Yeah.
But having said that, see, the perpendicular on the table can be anywhere.
Yeah.
So that is why we write lambda times C. Because this can be parallel to one another. The C vector that you get could be anywhere on the table, right? Perpendicular to the table.
Okay.
It need not be exactly here. It can even be here. But still it will be parallel. So lambda times C. So and when you cross two vectors, you get a vector which is perpendicular to two other vectors. True.
So you have to get it into lambda.
But you can always include a lambda. Where you'll include a lambda, when you do the sums, you'll understand. Yeah. So then when you want a vector which is perpendicular to other vectors, you have to cross those two vectors. When you want a vector which is perpendicular to other vectors which is in a plane, you have to cross those two vectors. Very, very important. Say it 1,000 times because I'm guaranteed you will miss this in the exam. So that's about it. And next is so you understood dot product, cross product. Okay. Next I want to do, what I want to do is triangle law. Okay, supposing I want to do a triangle law of vectors. Was it there in the video? Triangle law of vectors? Okay, so that's good that I'm doing this video. So you have an A vector. Okay, and you have a B vector like this. They both are in the same order. Same order means direction. The third vector in the opposite direction, this is A in the same direction, this is B in the same direction. The third vector in the opposite direction will give you the sum of these two. So C vector is equal to A vector plus B vector. Are you clear? C vector is equal to A vector plus B vector. What is the property? Triangle law states that when two vectors are in the same direction, the third vector in the opposite direction will give you the sum of these other two vectors. So the next is, if this is A vector, this is B vector, and suppose this is C vector, which are all in the same direction, then you can say A vector plus B vector plus C vector is equal to 0 because the net displacement will become 0. Where you started, you come there.
Yes.
Therefore, it means the net displacement becomes 0. So these two are known as triangle law. We can say it any way you want. Next is, I'll teach you, this is triangle law. I'll teach you about a parallelogram. Parallelogram. Was it there in the video, previous video? No. Again, parallelogram. Let me not write this. I'll say parallelogram. Okay, so then they will give you two adjacent sides of a parallelogram. So where they'll give you this as your A vector and this is your B vector. So when they give you two adjacent sides, you should know, you should draw only like this. You can't draw A vector like this and a B vector like this. You understand?
Yes.
It is fixed that when they give you two adjacent sides of parallelogram, it means this. So what you have to do is you want to construct into a parallelogram, you construct a B vector parallel to this B vector. So you can write this as B vector. Why
Same
didn't you write
magnitude.
lambda times?
Uh,
Because lambda is just 1,
one.
because it's got parallelogram, opposite sides are equal.
Yeah.
So lambda becomes just 1, I can copy it as B vector.
The magnitude will be the same.
Same.
Yeah.
So then therefore there's no need of lambda. Correct? Now you know this is A vector and this is B vector, and the resultant, which will be the diagonal in the opposite order, will be an A vector plus B vector. The word is resultant. Resultant means sum of the two vectors. Correct?
Yes.
Resultant simply means sum of the two vectors, addition.
Basically C vector.
That will be C vector. You can call it, or you can still call it as A vector plus B vector. So you have two vectors, you added that and you got the diagonal. Now, so let's do it with numbers. So let's A vector be 1i plus 2j plus 3k. Let B vector be 3i plus 6j plus some 10k. So what is A plus B vector? The resultant?
1 plus 3.
You can add an I, so it's 4i, a j and a j, so it is
K.
8k plus
13.
8j plus 13k. So we got this diagonal. They will ask you, now I'm going to rub all this off, okay? They'll ask you to do a vector parallel to this diagonal. So which means you'll do a parallel like this, and I'll write lambda times 4i plus 8j plus 13k. Why do you include a lambda? Because they've just said parallel. They have not said they have equal magnitude or anything. So there will be a value for lambda. So you write it like this. Thus you got a vector which is parallel to the diagonal. Now take the lambda inside. It will be 4 lambda I plus 8 lambda j plus 13 lambda k will be this vector. But the question would say, find a unit vector parallel to the diagonal. So you found a vector that has been divided by its magnitude. Because the question is not, the question is what we found is a vector which is parallel to the diagonal. We found a vector which is parallel to the diagonal. We're going to find a unit vector parallel to the diagonal, which means that vector by its magnitude. So then that vector is 4 lambda I plus 8 lambda j plus 13 lambda k. By the magnitude, it's a 16 lambda square plus 64 lambda square plus 169 lambda square, where the lambda anyway once comes out will get cancelled, which is within the root. So then you'll get a this 169, what 4 by root 16?
Yeah. 4 by root 16 plus 8 by root
No, this has to be solved, sorry. You can't do that. You have to add everything, no?
Okay, yeah.
So it's 4i plus 8j plus 13k. There is no i's and k's here, just 16, this will become 80. 169 plus 80 is 9, 6, 2, 12, 13, 14, 249. So this is your unit vector which is parallel to the diagonal of this parallelogram. World's most important question.
Okay.
So what is the question? They'll give you adjacent sides of the parallelogram. They'll ask you to find a unit vector parallel to its diagonal. Unit vector parallel to its diagonal. So they will give you only the adjacent sides A and B. So first is to find the diagonal by using triangle law. Then constructing a vector parallel to it which will become lambda times, and then converting that vector into its unit vector. Are you clear about the three stages? Very, very important. Are you clear? So the next is it's about the area of a parallelogram. Area of a parallelogram. Supposing they give you a vector and a b vector. I told you should only do it like this, right? And you can always do the b vector which is here and an a vector which is parallel, it's also a vector, you know all that, okay. Area of parallelogram is simply the formula magnitude of a cross b. You know a vector 1i plus 2j plus 3k, b vector 3i plus 5j plus 9k. You can simply cross it, you know how to cross by using determinants way. Get the answer and find the magnitude, and you have to write the answer as square units, because you would have found the area of the parallelogram by simply crossing it and finding the magnitude. Are you clear? Now, the area of a triangle. Area of a triangle where two adjacent sides will be given. You know the formula will be merely half of magnitude of a cross b, because area of a parallelogram divided by 2 will give you the area of the triangle. So this is the formula to find the area of the triangle. Next, the next thing I want you to know is area of the triangle. Okay. Using diagonal, how to find the area? Okay, supposing you have a parallelogram. This is diagonal 1 and this will be diagonal 2. You know, diagonal bisect each other. So diagonal 1 will become d1 by 2 and the diagonal 2 will become d2 by 2. This is now area of a triangle.
Yes, ma'am.
And what is the area of triangle? Half of d1 by 2 cross d2 by 2, which means 1 by 8 can be taken out common. d1 cross d2 gives you one triangle's area. Like that, how many triangles you have? So it's 4 times. So therefore it is also, if you know 2 diagonals also, you still can find the area of the parallelogram. What is the area? It's half of d1 cross d2 will be the area of the parallelogram if you know 2 diagonals. Are you clear? The 2 diagonals in the vector form. 2 diagonals will be in the vector form. You know how to cross the 2 diagonal, I, j's, k's and determinants way.
Yes, ma'am.
And then divided by 2 because formula is half of d1 find the magnitude and divide by 2. Are you clear? So this is how we find there's another proof where we can also find the area of the parallelogram using its diagonals.
Ma'am, this is both the diagonals, right, ma'am?
With using both its diagonals, it's half of. They'll ask you to prove this also.
Okay.
This itself is a proof. Everything in here, whatever I'm teaching, itself can come for board exam.
Alright.
Don't think only the exercise will come. So I'm going to only do the exercise. Intro video should be thorough. You should be able to take a notebook and write what I taught in the intro video without seeing the intro video so that you are clear about the concepts. Okay, this is what it is. And beyond this, we can refer to the other intro video. So what do I name this intro video as? Is there anything? I left a projection, right? In this I have not spoken about the projection. Supposing you have a B vector here, you're going to project it on A vector. So if physics if you have either kokoroko, we'll break it down into 2 components. If B is like this, we'll assume this is theta and we'll write this as B cos theta and this is B sin theta. In physics we always do that.
Okay.
So then projection of B vector along this is magnitude of B into cos theta, because you can't have a B vector because cos theta has been included. So cos theta included means you know which direction it is.
Okay.
Correct?
So cos theta represents the direction of this?
Yeah, absolutely.
Okay.
Once you include theta, you know the direction. No?
Alright, yes, ma'am.
A 45 degree east of north, a 30 degree.
Okay.
You understand. So therefore, the projection of B vector on A vector, if you know theta, will be magnitude of B into cos theta. Correct? But you know cos theta's formula. This is one formula, and cos theta's formula is A vector dot B vector by magnitude of A into magnitude of B. So magnitude of B and magnitude of B will get cancelled. A vector by its magnitude, which is A vector, it will become A cap into B vector. Therefore, you understand, if you are projecting a vector, there is B vector on A vector, you don't need anything other than the direction of A vector, which is just A cap and dotted with a B vector. You should know that it can even be written as B vector dot A cap because dot product is commutative.
Alright.
A dot product is always commutative. That is A dot B is the same as B dot A. But a cross product is always anti-commutative. And you can't just like that switch it. Okay. An A cross B will become minus of B cross A.
Okay.
So this is something you need to
The
know.
determinants will change, right? So because of that.
Yeah. Okay, they are not the same value. Okay, so A cross B is minus of B cross A. It's anti-commutative. Okay, so the next thing I want to tell you is supposing you have an A vector here, and you know the B vector is like this, and this A vector is 1i plus 2j plus 3k, and they've given B vector to be 3i plus 6j plus 12k, whatever. So you know how to find this diagonal because you know you will construct B like this and you will construct this vector which will be like this. It is easy for you to do this because it's just resultant of this and this vector now. But I am asking you to construct the other diagonal. If I am going to ask you to construct another diagonal, what is the other diagonal? It will be like this. If you are going to go from top to bottom,
Yeah.
this is another diagonal, which means you need B in this direction. Because this has to be in opposite order to this and this. You already have it in this is already in this direction, no problem. Correct? But the B vector is actually facing up. But you don't need it. You need to be facing down. That's when you can apply a triangle law for this. Because this line in here represents the sum of the other two, which means the other two has to be in opposite order. So if you know B vector so much, how do you write this? This is minus 3i, minus 6j, minus 12k.
Okay.
You should
So it's
change
the
the
negative
vector
of the
because
vector.
negative of the vector. So then now this you know is whatever vector, and then you can add this and you get the resultant. You can add this and this vector and you can get the resultant. So there is an involvement of reversing this direction when it comes to finding the other diagonal, which itself could be a question, which itself could find the other diagonal or find the two diagonals. So you will write one diagonal vector, but you won't know how to write the other diagonals vector. But in that case, you know you should write the b vector to be reverse of the b vector and change all the symbols and then add it with the a vector. You get the other diagonal. Are you clear? So that's another point that I would like to tell you. In any question randomly, they say that a vector is a unit vector. Then you should immediately write magnitude of a is equal to 1. They say b vector is a unit vector. You should immediately write magnitude of b is equal to 1. They will say the sum of the two vectors is also unity, which means magnitude of a plus b is also equal to 1. Whenever the question is like this, it is very obvious they're going to ask you the angle between a and b. So you need to take this and square it. So when you square it will be magnitude of a the whole square plus magnitude of b the whole square plus 2 into magnitude of a into magnitude of b into cos theta is equal to 1. So question is about finding cos theta. You know this is 1. From here you know this is 1 plus 2 into this 1, this is 1. So cos theta is equal to 1. 2 plus 2 cos theta is equal to 1. 2 cos theta is equal to minus 1. Cos theta is equal to minus 1 by 2. So you will know that they are asking, they're going to eye on it. Okay. Similarly, there will be questions where they'll say the sum of the three vectors is equal to 0. A vector plus b vector plus c vector is equal to 0. Then immediately you should write magnitude of a plus b plus c is equal to 0. But even before writing that, if the question is about finding the angle between a and b, take the c to the other side. If finding the angle between a and c, then take the b to the other side. So let's keep it as finding the angle between a and b. Therefore, which one I'm going to take it to the other side?
C.
So a plus b is equal to minus c and the magnitude. Correct?
Yes, magnitude.
So we can square both sides. When I do that, it will become magnitude of a the whole square plus magnitude of b the whole square plus 2a magnitude of a into magnitude of b into
Cos theta.
Cos theta is equal to magnitude of c the whole square. You know, if this is given as unit vector, then this will be 1 plus this will be 1 plus 2 cos theta is equal to 1. So 2 plus 2 cos theta, whatever, then you can find out what angle. I didn't find the angle here yet. Now cos 60 is 1 by 2, but it's negative. You know, all school torture children, second quadrant is when the cos will be negative. So it will be 60 degree will become pi minus pi by 3, which is 2 pi by 3 will be answer for this question. So like that you should be able to, when they give you like this, it means you have to take one to the other side depending on which angle they want. Are you clear? So the next thing is about, so let's do some proofs which are not there in that video. I just want to do more in this video. 2 plus 2 cos theta is equal to 1. So 2 cos theta is equal to minus 1. Cos theta is equal to minus 1 by 2. We just saw the like a previous sum. The same angle 2 pi by 3 will come. So you understand the when they give this itself, you know they are talking about an angle between a and b. That you know that should be the question. So you know that c can be taken to the other side. So let's go to next. Okay, let us record, and so then everybody can take it from the recording. The vector addition proof. There's a property that the vector addition a vector plus b vector is commutative. Is equal to b vector plus a vector, and the proof for this. How to write the proof for it? They generally don't ask for proofs, but what they ask. So in the introduction itself, let's learn it. So this is your a vector, and I told you your b vector has to be always written like this. Didn't I tell you? When they say a plus b, your a has to be like this, b has to be like this only. Okay, so then you construct a b vector like this, and you know that when you do a diagonal like this, yeah, by triangle law you get a vector plus b vector. Now you do the same thing. You take that side, you take this side. This is your b vector and this is your a vector. This is your a vector. Now this is the same opposite direction, right? Still that will be b vector plus a vector. Therefore a vector plus b vector is the same, b vector plus a vector is the same as a vector plus b vector. Are you clear with the proof? With one diagonal itself you are able to prove that, and that's beautiful. So let's go to next question. The next property proof, property 2, where they say a plus b plus c is equal to a plus b plus c. Okay, this is like associative, right?
Distri-
Distributive means you will take it inside. So this is just associative property. This is commutative property, commutative, and this is associative property. So let's see how to do it. Let's draw a quadrilateral. Okay, they have given A, B and C. So you have to draw it differently. Let me show you how to draw it. If you don't know this, you can't. This is your A vector. This is your B vector. And this is your C vector. All of them taken in the same direction, correct? Because the sum of it will be A plus B, which will be in the opposite order. This is a polygon. I taught you triangle law. Like that, there is also a polygon law, where if all sides are in the same order, the last side in opposite order will give you the sum of all the three. So then therefore you can write a vector in this direction, which will be given by A plus B plus C. But since you have to prove it's associative, you have to be methodical. So then just go for this diagonal first. This will be A plus B. Now A plus B plus C. So when you write this purple color line, it will be green color A plus B, be a green color A plus B, plus the purple color plus a C. So you got it like this. So same diagram, you take it and draw on the other side and do a diagonal in the opposite direction. You will get the A plus B plus C. So let's do it. So this is your A vector. This is your B vector. And this is your C vector. And so then I've drawn it. But the thing is, I'm going to do the third vector in the opposite order like this only. Yeah, fine. Like this only. But before which I have to do a diagonal green color in this direction, so that I will get a B plus C in the opposite order. So now that B plus C and A are in the same order. So this will be A plus B plus C, which is in green color. So that proves it is to be, they both are the same, because we've taken the same quadrilateral and proved it. Are you clear? So that proves the associative property. So next one. Okay, now actually speaking, when I said area of the parallelogram which can be calculated using diagonals, area of parallelogram is merely A cross B is magnitude, correct? You can also write it as half of D1 cross D2 when you know the two diagonals. Actually speaking, this formula is actually applicable for an area of a quadrilateral. Okay, area of a quadrilateral. But every parallelogram is a quadrilateral. Therefore, we are using this formula. But actually speaking, this is an area of a quadrilateral. Okay, so then the whole thing, this is a quadrilateral. The same diagram applies here. So you will the same proof applies here. Instead of what you did on a parallelogram, okay, let's do this proof. How is the area of a quadrilateral? Half of magnitude of AC cross BD. Okay, AC cross BD. Where is AC and BD? There's no diagram here. Okay, so let's do a quadrilateral which is like this, like this, like this, and like this. Yeah, this is a quadrilateral, correct. So let me name it as ABCD, ABCD. Okay, and to show that it's half of AC, let's join this, and half of BD. We know this is the formula, but I'm trying to find a proof for this area of the quadrilateral itself. Okay, I did it for area of a parallelogram. I could do it because diagonal bisect each other, so I would write D1 by 2 and D2 by 2, and I could cross half of D1 by 2 cross D2 by 2, 1 by 8 vandada. There are 4 triangles which is similar triangles, so I could just multiply it with 4. But here it's not going to, I'm going to have a difficulty is what I think. Let us see. Let's call this center as O. Let's call this center as O. Now if I want, let the diagonals intersect at O. Now if AC, what is AC? What is an AC vector? Is AO vector plus OC vector. That is what is an AC vector. Similarly, what is a BD vector? A BD vector is BO vector plus OD vector. Okay, now therefore half of AC cross BD, half of AC cross BD, which is directly the formula itself. He is taking the formula itself. Okay, half of AC cross BD can be written as half of, what is AC? AO plus OC. into BO plus
BD.
OD, no?
OD.
BO plus OD. So now this is nothing but okay, half of BO plus half of AO cross OD. I'll explain to you what he has done, plus half of OC BO plus half of OC OD. There's a cross here, okay. Let's try to make it distributive. Let's try half of AO cross BO plus half of AO cross OD plus half of OC cross BO plus half of OC cross OD. When I did this distributive property, I realized that this is nothing but the area of this triangle 1. Correct? Triangle, area of the triangle AOB plus area of the triangle AOD plus area of the triangle OBC plus area of triangle OCD. So then all that will contribute to area of the quadrilateral. Yes, so I have proved it. I am literally taking quadrilateral. I have literally used the formula and trying to justify that this formula will head to the area of a quadrilateral. I am taking the quadrilateral's formula. I am proving that that was what it would be.
Okay.
Farida?
Yeah, you're using the formula.
So which means what I could have done is just copied this in reverse, so that I would have got the area of the quadrilateral.
Yeah.
You agree with me?
Yes, ma'am.
I could have done area of this and written this statement. After this statement, I can simply copy this statement. Only provided I know the order, I can write in reverse and thus prove this. Isn't it brilliant way?
Okay, yes.
So then make sure they ask you this question, you do it in reverse order, but for which you write from the beginning and try to ulta it. Okay. The whole point I would like to reiterate here is that this formula half of D1 cross D2 applies only for a quadrilateral, but every parallelogram is a quadrilateral. So I could incorporate this in that. Are you clear?
Yes.
So that's about it. So whenever they give you position vectors of quadrilateral, yeah, you know this is A, B, C, D or the position vectors. Position vectors means it's always with respect to the origin.
Yeah.
So you should find what is AC vector. You know A and C. You should do C minus x2 minus x1 so that you get the AC vector, which is diagonal 1. Similarly, you have to do DB vector or BD vector. So basically, supposing this is A, B, C, D is the parallelogram. In this parallelogram, I did a diagonal DB. But generally, when you draw a diagonal for a parallelogram, okay, you should draw it like this is one diagonal and this is another diagonal. This is the way you should draw. But however, if the question was finding DB, I did it like this, where I wrote the negative of B. But otherwise, if it is like this, you know this is already like this in the opposite order. So you'll write the A in the negative direction. You understand? So generally the diagonals is always from here, it goes like this and goes like this. However, here if the question was about DB, then I had to reverse the direction of B. If the question is about BD, then I should reverse the direction of A. I hope you got this point very clear. Everybody should be very clear with this. So going back to what I'm going to do in this. So when I have, normally what you do AC, which is C minus A vector, and you want a BD, not a DB. In general, if they don't specify, we only need a BD. How do you know from here, from the previous equation, we did only a BD. We only did a BD and an AC. Therefore, the diagonals have to go only generally in this direction. Are you clear? But however, in that I showed you some other diagonal which was in this direction and I showed you how to calculate. Because what if the question changes? That's what it is. Are you clear? So that completes this. That's how you calculate the area of the diagonal, area of the quadrilateral. So now I'm going to introduce you to something called a scalar triplet. A scalar triplet. Scalar triplet. A scalar triplet means it's like A vector, B vector and C vector written like this in brackets. What is the meaning of this? The meaning of this when it's written within the bracket like this means it is A vector dot B cross C. A vector dotted with B cross C. And it can also be, this is the same as B dot C cross A. It will be the same as C dot A cross B. Why? Because you can also prove this. You can consider that A vector is A1I plus B1J plus C1K. This is A vector. What is B vector? A2I plus B2J plus C2K. What is the C vector? A3I plus B3J plus C3K. What is the scalar triplet? Dot. It is dotting and crossing. A dot B cross C, which means it's nothing but determinants. Don't write I, J and K. Instead write A1 B1 C1, A2 B2 C2, A3 B3 C3. Writing a determinant like this shows that this is being dotted with a cross product of these two. The first line is being dotted, that is A vector is being dotted with a B cross C. A determinant simply can also mean dotting and crossing. So then I have three vectors. You know, okay, that this is the same as B dot C cross A, because even if I write B here, that is A2 B2 C2, then write C, which is A3 B3 C3, and then write A1, which is A1 B1 C1. According to determinants, that's a property. Okay, this properties have been omitted, but let me tell you, you exchange one row, you get an answer will be negative. You exchange two rows, the answer will become positive. Because here two exchanges have happened. That is, this has come here and that has come here, which means two exchanges will result in a negative plus negative positive. So this answer and this answer will be the same. Similarly, the proof. Therefore, ABC is the same as BCA is the same as CAB, and such is called dotting and crossing, which means A dot B cross C is the same as B dot C cross A is the same as C dot A cross B. Are you clear? It's called a scalar triplet. Okay, in other words, it's also called the area. It's also called the volume of a pipette or parallelepiped, whatever you call it. Volume of a parallel pipe. A parallelogram or 3 dimension. A parallelogram, you know how it is? Okay, you know this is x-axis, y-axis, z-axis. So you will have a parallelogram, say this is a parallelogram and a 3-dimensional parallelogram. You know what I mean?
Yeah, I get it.
I don't know how to draw it though. Che. What?
Instead of drawing it parallel to x-axis, you can draw it downwards.
This one cannot be from here, no? This has to be here. Huh? Yeah? Something like that is a parallelepiped, correct? Actually speaking, no, I will do it like a cuboid only, so it's easier for me. This is x-axis, y-axis, and anyway z-axis is involved. I'll draw like this, and I'll draw like this and like this and like this and like this and like this, and I'll tell that this is parallelepiped. You must believe it. Yes. It's a parallelogram convert, but because every cuboid is a parallelogram. So you know this is the origin, right? And this is your A vector, and this will be your B vector along y-axis, and this will be your C vector, and all of them is from the origin, correct? So this is A vector, B vector and C vector. Therefore, if you want to find the volume of it, is L into B into H generally. It's like that, it's A dot B cross C. Are you clear? Or a B dot C cross A, or a C dot A cross B. And you know this is nothing but determinants. Correct? If you know the vectors, you can write all the three in the determinants, first row, second row, and third row. So therefore, since you have understood this, which is not even a part of the portion, you know what is coplanar. A coplanar means there is no 3D. Coplanar means all of them lie in the same plane.
2D.
All of them lie in the same plane. All the vectors have to lie in the same plane, which means the volume of the parallelepiped has to be 0. So the determinant value of the three vectors, suppose they give you three vectors, A1, B1 and C1, and they ask you if they are coplanar, the determinant value has to be equal to 0. This is A vector, this is B vector, and this is C vector. To prove that what is A vector is let's call it 1i plus 2j plus 3k. Let's call B vector as 2i plus 4j plus 5k. Let's call C vector to be some random 3i plus 9j plus 12k. You know that determinant value has to be 0. That's when there is no volume for a parallelepiped. So it will not be 3-dimensional, it will become a single plane. So condition for coplanar is simply determinant 1, 2, 3. 2, 4, 5, 3, 9, 12 is equal to 0. That is the condition for coplanar. Or in other words, A1, B1, C1, A2, B2, C2, A3, B3, C3, which is this A vector, this B vector and this C vector will always be equal to 0 if it is coplanar. So they will give you 3 vectors with one value as lambda. So when you substitute, one of it will be lambda. That is equated to 0. You know how to find the determinants? Positive, negative and positive. Just freeze it, find the value of lambda. When you solve it, you will get the value of lambda, correct? Are you clear? So this is what it is. This is a condition for coplanar. So the next thing that I want to tell you, so basically you do this when 3 vectors are given and they ask you if they are coplanar. The 3 vectors are coplanar, the determinant value has to be equal to 0. So then that is a proof for it to be coplanar. Sometimes they'll change the question and give one of the points, one of the coefficient to be lambda, and they themselves will say it is coplanar, then equate it to 0 and then find the value of lambda. You know how to, you can freeze this first row as 1 into, minus 2 into, and plus 3 into. And you know when you do 1 into, you'll remove that row, that column, top to bottom minus bottom to top will be 12 4s are 48 minus 9 5s are 45. Top to bottom minus bottom to top. What is your problem?
12, okay, that's 12.
Okay, so minus 2, because I told you there has to be minus 2 into, ignore that row and that column, do top to bottom minus bottom to top, which will be 12 lambda minus 15. Next plus 3 into, ignore that row and that column, sorry, do it with blue color, that row and that column, do top to bottom minus bottom, 9 lambda minus 12 is equal to 0. What is the meaning of this? This means 0i plus 0j plus 0k. This is just determinants. So then therefore you will get only your crossing. You are supposed to get only a vector, but this is not a vector because we have dotting and crossing. You are crossing and yet dotting, so it will become a scalar. A cross product will result in a vector. You are dotting with this, eventually you are dotting, right? So it will result in a scalar. So then this is not 0i plus 0j, it's just 0, that's all. So then just solve it, you get the value of lambda. Solve it, you get the value of lambda. Such question usually comes for the boards, where they give you 3 vectors, they'll ask you if they are coplanar. To prove it's coplanar, the determinant value has to be equal to 0. The next question is, they will say it is coplanar, they'll ask you to find the lambda. In that case, this means dotting and crossing, which will eventually not result in a cross product, it will become a scalar only. It will become a scalar because we are eventually dotting it with an A vector. Even though we are doing a B cross C here, we are dotting it with this, and a dot product should result in a scalar. Okay, are you clear? So that is one thing that I want to tell you. Here is the world's most important question, which has come for previous board exams. Okay, the question is, the 2 vectors, one vector is j plus k, another vector is 3i minus j plus 4k. They represent 2 sides of a triangle. So the 2 sides of a triangle, they have given it as AB vector and AC vector. They themselves have specified it. So when you draw it, you know that AB vector has been given and an AC vector has been given. And this is what is j plus k and this is what is 3i minus j plus 4k. They are going to ask you, find the length of the median through A. Find the length of median through A. It's the world's most important question. So you're going to draw a median. Median means it's going to bisect the opposite side equally. The question is to find the length of this median. Let's call this triangle as ABC and AD is the median. Let AD be the median. So they want the length of the median. They want the length of the median. So then how to do the sum? Can you see? We can find what is BC. We can find what is BC. If you're going to take BC in this order, the other sides have to be in opposite order. So can you see this side? No, BC is in this order. The other side has to be in opposite order. Perfect, this is opposite. But this is not opposite. So for that you have to change it as minus j minus k and write it like this. So that you can write your BC vector to be sum of the other 2 vectors, which is minus j plus k, which means 0i minus 1j minus 1k can be added with 3i minus j plus 4k. So when you add, you will get a 3i minus 2j plus 3k plus 3k. So thus I got my BC vector, which is in this direction. And you know that this AD is a median which is going to bisect this. So I can write a BC vector divided by 2. So then this half will be 3 by 2i minus 1j plus 3 by 2k. That is what is that in the direction. What is the direction? The direction is DC. I got DC. So now that I got a DC vector like this, yeah, I can find AD. Where, which is the direction of AD? AD is going to be like this. Therefore, you don't need DC, you need minus DC, because it has to be in the opposite order, correct? Taking this triangle, so then this will be minus 3 by 2i plus 1j minus 3 by 2k. What is your doubt?
Ma'am, can you not take this side? Since both of them are being bisected, can you not take this side as...
Now, I've chosen, you have chosen one triangle.
Okay.
So let's continue to do that and see if you're getting the answer. If you don't get an answer, I'll tell you. So then this is this vector, which is DC vector, which is CD vector, sorry, which will be CD vector in the opposite direction, right? Because you need it only in the opposite direction. That's when you can apply a triangle law, because this is in blue color is downward. So therefore, we can add both of them. What is 3 minus 3 by 2? So it's 3 minus 3 by 2 into I plus minus 1 into j. Minus 1, I'm adding, correct? Plus 4
plus 3 by 2.
Plus 3 by 2 into k. I'm just supposing to add, and I'm doing that only, no? So if you take LCM, 6 minus 3, 3i minus 2j, 8 plus 3, 11 plus 11k. Correct?
This is 3, right? Ma'am?
This is 3 minus 3 by 2. 3 2 so 6 minus 3. Oh,
Yes, ma'am. Won't it be 3 by 2?
6 minus 3 is 3 by 2i.
Yeah.
Minus 2j, and this will be 11 by 2, is it? I forgot that also. 11 by 2 k, and that is what is my AD vector. So now I have done this sum. Let us check if my answer is correct. Okay, they are asking for the length of the magnitude, which means you are going to find the magnitude of this, which is root of 9 by 4 plus 4 plus 121 by 4. So let's take an LCM, which is 4. So it's 9 plus 16 plus 121. So this itself is 130. So it will become 146, is it? 146 by 4, is it can we cancel 73? We are not able to cancel. So we are getting something like a root 73 by 2, which is wrong. I noticed that I have made a mistake here. So this is your vector that you have to consider, and you are supposed to add this and this, correct? So when you add, it's 3 minus 3 by 2 minus 1 plus 1, and a 4 and a minus 3 by 2, no adding. Here also I made a mistake, right? Correct? Yes or no? Because I made a mistake, quite a lot of mistakes there in calculation. So this will become 6 minus 3 is 3 by 2i. This will become plus 0j, and this will become, what is the 8? 5 by 2. 5 by 2k. I hope I am doing it well now. I hope there is no mistakes. So then if you find the magnitude of this, it will be 9 by 4 plus 25 by 4, which will be root of 34 by 4, yeah, which will be root 17
by 2.
17 by 2. So root 17 by root 2 units will be the length of the median. So I made a calculation mistake. This is a very, very important sum. I'll explain this once again. So let's name it as, this is A, B, and C. They have given AB vector. They have given AC vector. You can find a BC vector which is in this direction. So the other sides have to be in opposite order. So this is okay, but this is not okay. This has to be in this direction. So you reverse all the symbols and write it in this direction. Then you add this and this, you get BC. Then you divide BC by 2, you get half of this. You write that vector. However, to find A, they are asking AD, which is in downward direction. This is in perfect order, opposite order. But you don't need DC, you need a CD. So whatever you divided by 2, you have to write an opposite symbol. So this will be equation 1, the changed one will be equation 2, and add them, you get AD vector, and the magnitude of it is root of the component square, so that you get root 17 by root 2. Are you clear? Beautiful sum, very important sum. Instead of doing this okay, whole thing, you already have a BC divided by 2, which is nothing but BD. You can also use this triangle. This is so convenient because this is already in the order that you want it to be, and this is in the opposite order. It's a brilliant way of doing, and I agree totally with you that I could have used this triangle. It would have been a lot more simpler. I make sure, guys, that you're going to use only the left triangle. Are you clear? The next question that I'm going to do here is find a vector of magnitude 5 root 2. Vector's magnitude has to be 5 root 2, making an angle pi by 4 with the x-axis, pi by 4 with the x-axis, pi by 2 with the y-axis. So you can't see it here. It's a 3 dimension, so it is not appearing to be a 90 degree. But you know the alpha, so don't do this. Just write alpha to be pi by 4, beta to be pi by 2 with the y-axis, and acute angle theta with the z-axis. So your gamma is just theta here, which is acute. You already know cos square alpha plus cos square beta plus cos square gamma is equal to 1. You can use that and do this. What is cos square pi by 4 plus cos square pi by 2 plus cos square theta is equal to 1. So then what is 1 by root 2 whole square is 1 by 2. This will become 0 plus cos square theta is equal to 1. Cos square theta is 1 minus 1 by 2. Cos square theta is 1 by 2. Therefore, cos theta is 1 by root 2 with a plus or minus, correct? But it is an acute angle. Since they have specified, this is where we will miss. Since they have specified it is an acute angle, it cannot be negative. Therefore, it's plus 1 by root 2. Such a board question, okay? So, there is another board question which I am going to discuss here. Find the angle between the x-axis. When you write notes, please write the question. Find the angle between x-axis and the vector I plus j plus k. They are asking you to find the angle between x-axis and I plus j plus k. What is the meaning of x-axis? Can x-axis, okay, angle between x-axis and a vector I plus j plus k.
So it will be 0y plus some value j plus some value k.
No, x-axis. Find the angle between x-axis and the vector I plus j. Let's call this as a vector. So this is a vector, okay? And so a vector, we are trying to find an. Okay, you know, this line x-axis itself. Let's go to x-axis. X-axis, what is cos alpha? Cos 0.
Yeah.
Cos x-axis itself will be cos alpha will be 0.
Okay.
If you take x-axis to be a line, can you imagine it is making an angle 0 with the itself? So can I say it is cos 0 into I plus cos 90 into j plus cos 90 into k? Can I say x-axis like that? Can I? So all you know is it's 1i plus 0j plus 0k. And the angle between this vector and this vector is what they are asking. So I would do it as cos theta is equal to this vector dot that vector, which means what? 1i plus j plus k dotted with this, which will be just 1, dotting i's and i's.
Yeah.
By magnitude of this, which will be root 3, into magnitude of this, which will be 1. So therefore you get cos theta to be 1 by root 3. Therefore theta is what they want, which is cos inverse of 1 by root 3. Where will cos be 1 by root 3? You don't know an angle where cos will be. Do you know an angle where cos will be 1? You know this, where cos 60 is 1 by 2. Cos 30 is root 3 by 2. You don't know where the cos will be 1. So leave it like that. Theta is equal to cos inverse of 1 by root 3. Are you clear? Do you understand how I for a minute stopped and wrote what is the vector of x-axis? That's not what this guy has done. But I don't want to copy from any website or anywhere. I want to think like how you would think in an example. What is an x-axis? X-axis itself is a line which would make an angle 0 with x-axis and a 90 and a 90 with a. So you can write that vector itself, correct? So this is another board exam question that I am going to deal with. If a magnitude of a cross b, the whole square, plus a magnitude of a dot b, the whole square is 400. And they have given that magnitude of a is equal to 5. Then write the value of magnitude of b. This is the question. The moment they give you magnitude of a cross b the whole square, What is the meaning of that? You know the formula for
magnitude of A
magnitude of B into sin theta. Okay, magnitude of A cross B the whole square can be written as magnitude of A into magnitude of B into sin theta. Veru A cross B's formula is this.
Okay.
The whole magnitude,
Okay.
which means it will become it will no more be a vector, right? The whole square also is there. Even if there is an direction, it will get squared, so then there won't be any direction, I think. Correct? So then this will become magnitude of A the whole square, magnitude of B the whole square into sin square theta. Plus this one, A dot B, which is magnitude of A into magnitude of B into cos square theta, because AB cos theta. The whole magnitude, the whole squared also, no negatives, so is equal to 400. So what? A square and B square.
Yeah.
So you can take it out common. So you take it out common as sin square theta plus cos square theta will become 1. So magnitude of whole square into magnitude of B square into sin square theta plus cos square theta common is equal to 400, where magnitude of A itself is 5. 25 B square is equal to 400. Correct? So magnitude of B square is 400 by 25, which can be directly written as 20 by 5, which is nothing but 4. A magnitude of B square
B is equal to 4 because you are rooting it.
already rooted
Yeah.
it. So magnitude of B is equal to 4. And shouldn't it be plus or minus?
Plus or minus, because it'll minus 20 into square is 4.
But having said that, magnitude means it has to be only positive. Magnitude is not determinant. Magnitude means length. I told you what is the magnitude of the radius, means
Yeah.
length. Can length be negative? So wherever they ask you magnitude, it will never be negative. So you have to write only a plus 4. These are the small key things that you have to notice. So let's go to the next thing. Have you recorded it? This is one simple board exam question. They're asking you to find a vector. Find a vector perpendicular to A vector and B vector. I told you scissors. When you cross A and B, you get a vector which is perpendicular to. Okay, but they are asking find a unit vector. Then you know its magnitude of an A cross. You have to cross these vectors. Sorry, A vector cross B vector by magnitude of A vector cross B vector. The vector by its magnitude. So this is the answer. It's 1 mark question. So let's look at the question. Find the magnitude of x vector if a unit vector A, which means magnitude of A is equal to 1. They say unit vector A, the word is there. Okay, they have given x minus A into x plus A is equal to 15. What is the meaning of this? A square minus B square. So magnitude of x square minus magnitude of A, the whole square itself is 15. A itself is given to be 1. So magnitude of x square minus 1 is equal to 15. So magnitude of x the whole square is equal to 16. And therefore magnitude of x will be just 4, because the word magnitude has to be only plus 4, no minus 4. Are you clear? That's a key point which we will forget. The next question here that has come for board exam is find lambda. Find lambda, for which they given A vector to be lambda I plus j plus 4k. A B vector to be 2i plus 6j plus 3k. They are saying when the projection of A vector on B vector is 4 units.
Okay.
They are saying the projection itself is
4 units.
4 units. What is the A vector on B vector? Projection of A vector on
B vector.
B vector. When the projection, what is being projected? Find lambda when projection of A vector on B vector. So the A vector is getting projected on B vector. You know the formula is that vector which is getting projected into B cap. Dot B cap.
Yeah.
Okay, what is A vector? Lambda I plus j plus 4k to B cap. What is the B cap? What is the magnitude of this? Root of 4 plus 36 plus 9, which will be root 49, which is 7. Therefore, the B cap itself is 2 by 7i plus 6 by 7j plus 3 by 7k. So, you have to dot it with this 2 by 7i plus 6 by 7k plus 3 by 7, whatever that is. I's and i's. So, 2 lambda by 7 plus 6 by 7 plus 4 is 12 by 7 is equal to, they have given the projection itself is 4 units. So when you do 7, it is 2 lambda plus 18 is equal to 4. 2 lambda plus 18 is equal to 7 4s are 28. So 2 lambda is equal to 10. So lambda is equal to 5. Thus you can find the value of lambda. This is a book sum only. If A vector dot A vector is equal to 0 and A vector dot B vector is equal to 0, then what can be concluded about B vector? What can you say about B vector? About B vector. So A vector dot A vector is equal to 0 means what? You're dotting an A and A.
Yeah, so it is essential.
What? When will the dot product be 0? When will the dot product be 0?
Cos theta is okay. I cap.
No, 90 when they are perpendicular. Is it when it's 90 degrees? Is it possible for A vector to be perpendicular to A vector?
Yeah, no, it's not.
It's never will it possible. So this situation can never exist unless the A vector itself is 0. Unless the A vector itself is 0. So the B vector can either be 0 or not 0 also.
Oh,
So
any number.
it can even be any vector. So then A vector dot A vector is equal to 0. Maybe conclude the B vector is either 0 or non-zero perpendicular vector. No, I am saying this condition itself is not true, because A vector can, when you dot it, it is 0 means they have to be perpendicular. Never can A vector be perpendicular to A vector. Therefore, the A vector itself has got to be 0. Clear? If A vector itself is 0, B vector need not be 0. Still the dot product will become 0. So B vector need not be a 0 vector. It can be any vector, or it can also be a 0 vector. Correct? They are saying B vector is a perpendicular vector to A vector does not even exist. Do you understand what I am saying? So then the solutions in the internet are not right, but this is the way you should write. Okay. So let us. This is the question I was talking about. If A vector plus B vector plus C vector is equal to 0, the magnitude of A vector is 5, the magnitude of B vector is 6, the magnitude of C vector is 9. Find the angle between A and B, which means you have to take C to the other side. So A vector plus B vector is equal to minus C vector. Squaring magnitude the whole square is equal to magnitude of C the whole square. So this will become magnitude of A whole square plus magnitude of B whole square plus 2 into magnitude of A into magnitude of B into cos theta is equal to magnitude of C the whole square. You know the values, this 25, 36 plus 2 into 6 5s are 30, so 60 cos theta is equal to 81. So take it to the other side, find cos theta, correct? And you will get cos theta to be 1 by 3, and theta therefore is cos inverse of 1 by 3. This is one board exam question. This is another world's most important question, where they find x such that the 4 points, what are the 4 points? Point A, which is 4 comma 4 comma 4, the point B, which is 5 comma x comma 8, point C, which is 5 comma 4 comma 1, and a point D, which is 7 comma 7 comma 2 are coplanar. You have to prove that they are coplanar. First of all, for coplanar you need only determinant value is equal to 0, which means you need only 3 vectors. But how many are there here? And they are points, they are not the line vectors. You have to convert them into line vector. Are you clear? So when they give you 4 points, which means they have given 4 position vectors, right? Which are all from the origin. So then for coplanar, this is the world's most important thing that I am going to tell you. Whenever they give you 4 points, you have to consider that they have given it from the origin. And so this itself is OA vector with the 4i plus 4j plus 4k. You understand what I am saying? So let's write what is a OA vector. So let's write what is a OA vector. OA vector is 4i plus 4j plus 4k. OB vector is 5i plus xj plus 8k. What is a OC vector? Is 5i plus 4j plus 1k. And then what is it? OD vector is 7i plus 7j plus 2k. You need AB, AC and an AD necessarily. AB, AC and AD. Everything has to start from, for coplanar, it means I am talking about a parallelepiped volume, which will all be OA, OB and OC. You can't do so if this is A, it's AB, AC and AD. The 4 points have to be taken like this.
Yeah.
So you can't do an AB. What I was saying, you can't do a BC and all. the starting point, this okay, or let's do one thing. Let's not write like this. Let's consider this as A, B, C, D, and you should write the vector AB, AC, AD. So how to write an AB vector? You know how to write AB vector, x2 minus x1. So 1i plus x minus 4 into j plus 8 minus 4 into k. What is an AC vector? You're comparing an A with a C. You'll get a 1i plus 0j plus minus 3k. Let's do an AD vector which is between A and D. 3i plus 3j minus 2k. So you have to necessarily, I'm writing it in red color, never forget, AB, AC, AD. Whenever they give you 4 points for coplanar, you consider that those points are A, B, C, D and do AB, AC, AD. Or you consider it as OA, BC. But O, when you consider, you'll think of it as origin. So no need. When they give you 4 points, let's consider it as A, B, C, D and find AB, AC, AD. Now you put it in determinants and that is equal to 0 will give you coplanar. But they've already given its coplanar. They're asking you to find the value of x. Correct? So 1, x minus 4, 4 instead of lambda. 1, 0, a minus 3, a 3, 3 and a minus 2. Solve the determinant and find the value of x. Are you clear? So this is using vectors. Find the area of the triangle ABC. Okay? And you know the area of triangle ABC is half of A cross B. Two vectors, you know, you can cross it and divide. But the thing is, what is given in this question is the position vectors such as this is 1, 2, 5. This is 5, what is this? 2, minus 1, 4. And this point is 4, 5, minus 1. But you need what? The half of magnitude of A cross B, where A is one side vector and B is another side vector. Correct? So therefore, so then I made, this is 1, 2, 3 it seems. This is 2 minus 1, 4. And this is 4, 5 and minus 1. This is the question. You know it's half of A cross B, right? But you don't know what is A vector and B vector. You know that we have to find a B vector which is BC, which is C minus B. Do you understand? What is C minus B? It's a 2, 4 minus 2, 2i plus 6j minus or minus 5k. Thus I found my BC vector, which is, I can call it as a B vector. I need an A vector, right? What is A vector according to me is BA. BA.
Yeah.
So I need an A minus B. So let me try. I might go wrong. Let me see. 1 minus 2 is minus 1i. 2 plus 1 is 3j. And the 3 minus 4 is minus 1k. Do you agree with me? I found what is A vector and B vector. I can simply substitute in half of magnitude of A cross B. And you know what is magnitude of A cross B means? I, j, k. This is your A vector. So minus 1, 3, minus 1. What is your B vector? 2, 6 and minus 5. Let's find the determinant freezing this. It's minus plus, okay, let's write plus 1. I into minus j into plus k into. 1 into means top to bottom minus 15 plus 6. Minus j into that row, that column moment. So it's 5 plus 2 plus k into that row, that column moment. So you know it is minus 6 minus 6. So I'm going to get this vector to be minus 9i minus 7j minus 12k, and it's a magnitude of it. So root of 81 plus 49 plus 144, and the whole thing has to be divided by half also. So what will this be? 81 plus 49 is 9, 10, 11, 12, 13. Plus 144 will be 1, 2, 74. Is it correct? I hope it's right. I'm capable of making mistakes like that.
81 plus 49.
Yeah. So then therefore this many square units. Answer is correct. You understand, when they give you points like this, you know that you need an A vector and a B vector. That's, you need a line vectors, and that should be in this direction. So therefore necessarily you have to do like this and get the value. Very, very important sum. I hope you're clear. Okay, similarly, I'm going to tell you one thing. They'll ask you this common question in your school where there'll be two vectors given. And they'll ask you to find a vector perpendicular to two of this.
Okay.
And it has to be unit vector. You know that lambda times That lambda may be
Anything.
plus or minus also, no? So far we are writing lambda, but you know that perpendicular means it could be plus or minus lambda, which I never said.
Yeah.
So you know that you can do a lambda times A cross B, where this lambda could be a plus or minus lambda times A cross B.
Okay.
So you will get two different answers.
Yeah.
Correct?
Yes.
So just remember this point, and I'm closing this video.